Hello to the Skoods friends. My name is Fernando Damasio. I'm founder and director of Skoods, director of competition. So I would like to explain what we are doing here today. So we are going to quickly talk about Skoods, what we do, also present the agenda of our competitions, our next competitions. Then we are going to do a quick TBT on how was the first competition, our first race, the Skoods Cup, the outcomes of the Skoods Cup, present how is the punctuation, the table of the competition of our teams. And then finally, we are going to dive in the simulation of the next competition, which is the mining challenge. I guess the main reason that we are all here to know more about the simulation, the challenge, the rules, and how to approach the challenge. During the whole live, I will invite our team, the Skoods team, and also the teams that are competing for in each race, each competition. And we are going to discuss about engineering, simulation, autonomous vehicles, and so on. So first, I would like to talk about Skoods. Skoods is we are born as a self-racing car team, and because we had nobody to race against us, we started to organize our competitions, right? And our goal was always to connect, to make the bridge between the racing tracks to real world applications. And definitely we can see that competition engineering will save thousands of lives in the future and will help improvements and development in the engineering side of society. So this is a brief explanation of Skoods. We have 2.5 years old, still a kid. And now I would like to talk about the agenda of competition. So presenting also our teams, for our teams, it's the first time that they see some changes in the agenda. So actually this is a gift also for our teams, right? So this is our agenda. We hold Skoods Cup in November. It was an amazing event that we are gonna quickly show a video here to do a TBT on this one. Now we are starting today the mining challenge and the true and the final challenge, and when all the teams will present their code for this challenge will be in February 21. Then we have the ready to unload competition in which is focused on transportation optimization in a port and terminals environment. The fourth competition, sorry, 1 second. Let me hide this. Yep, the Hungry Trucks competition will be held also next year. So it's in agricultural field. Next one, the fifth, is in an urban environment. We do have some, some dressing, some characteristics of a futuristic environment to bring some more fun to the challenges, right? But will be based on our day-to-day lives in urban environments. And finally, the moon race, which is a more ludic competition in which we have different challenges. We have low gravity, we have no friction with air. So also a very good environment to try and to apply different engineering solutions. Okay, this is our agenda. I hope you enjoy. And next, I would like to invite Guy, my partner and co-founder at Skoods and friend. Hi, Guy.
Hello, hello.
Please introduce yourself, talk a little bit about you, and also if you work with other stuff than video games for engineers. Okay.
Yes, together with Fernando, I'm co-founder of Skoods, and my whole here it's integration and simulation engineering. And out of my whole here in Skoods, I'm also data engineer. I work with a large amount of data and pipelines and ETLs, but it's not the main subject tonight. So, well, tonight we're gonna present you the new simulation that we are seeking to find a way to catch the environment from the mining environment. So it's a little bit different from the first one. That the main challenge was time and velocity. The faster team will be the winner. In the next one will be the smarter team that have the best strategy.
Perfect, Gui. Let me put on the video of the TBT. One second. I'm still learning to be a TV operator here.
Better you than me, for sure.
Okay, can you see, Gui? Please give me a feedback.
Yeah, perfectly. Yeah, here we can see inside of the boxes that we have in this racing track. And in this first event, we build this environment that's very close to a Formula One racing track. And the challenge was for the teams was speed and time. So in this first challenge, control was the main subject. Will be very different for the second one, the second challenge that we're gonna have in the mining environment. That strategy will be the difference between the teams. So if you were the faster, it not means that you'll be the winner in the second challenge. We are planning to do this because every challenge that we have and we're gonna have in the future will be a complete different parts of the stack of a completely stack of a self-driving car.
Yeah, going through the teams here, we presented all the teams. So here we have Art, guys from Embraer and ATEC, Steven representing the whole team. They were the winner of the first competition. Then we have FATEC, the autonomous race team, represented by Wesley, and also Professor Pitani, a big professor here in Brazil related to autonomous vehicles. Then we had Feedback Racing with Nicholas representing. Actually, Nicholas is a Skoods collaborator, also our internal collaborator as well, help us organize. Uh, Last night we slept 1.5 of a.m. So now we have GP car with Rafael, a professor from the Northeast region here in Brazil, a professor in the Instituto of Paraíba here representing the team. Then we have Silverstone, which was the second place, represented by the last race by Lucas Veronese. And today will be represented by Ren, which also help us organize Scoot as well. Finally, we have Vega from the University of Minas Gerais, represented by Felipe Ribeiro and the whole team. So this was the teams. Felipe Madeira can't join us today, but he interviewed all the teams in the past competition. And after presenting the teams, we went through uh, showing the competition. So we had 6 teams competing, and we did this. We show all the teams at the same time as it was a race against the clock. No multi-agent. Was a simpler competition for the first one, right? We need to learn, and teams had only 1 month to do so. You can see Silverstone that drift in the first curve there, then struggle to come back to the road. But this was just one drifting. Then they did very well for the rest of the whole race. You're going to see the top middle Patek doing some, some fancy movements after they had some problems when completing laps, probably related to connecting the waypoints from one lap to the other one. But yeah, they still were able to finalize the race.
We have a stunt here.
Yeah.
But the beauty is the algorithm taking control again. That's I believe one of the the best thing in the first challenge was all the teams completely complete the race, and we can see that the algorithms take control again even when the cars lose control.
Great. Then you have the final results of the competition. Art, Silverstone, and Feedback Racing, the first, second, and third. And Steven received the symbolic trophy in the end. And we had some final cool discussions around engineering and other stuff. So thanks for the team. Then also event. Now I'm going to stop sharing the video and present you how is the competition table right now. So Art with 5 points, the first one, Silverstone second one with 3 points, Patek, GP Car, and Vega with 1 point each coming third, and all of them as third, right? So great. Now we should dive in the main part, which is the simulation of the mining challenge. I would like to include here all the members of Skoods and the team. So please, I will include you guys. Please introduce yourself, Nicholas.
Hello, everybody. My name is Nicolas Rosa. I'm a PhD student at the São Carlos School of Engineering at the University of São Paulo. Currently, I'm researching deep learning-based perceptions techniques for autonomous vehicles. And here is Skoods. I'm part of the principal team. And as competitor, I was the leader of the feedback racing team that got the third place.
Great, thanks, Nicholas. Rafa, please.
Hey guys, my name is Rafael, and I'm professor at Federal Institute of Technology, and I'm working with GP Car, and we are really happy to be here. It's a lot of good guys here in this competition, so it's a really nice opportunity to learn more and to do this kind of competition here in Brazil. So that's it.
Thanks, Raf. Not only Brazil, right? Now we have a Brazilian-Australian guy. Hi, Ren. You're muted.
Good evening, everyone. I was muted, and my name is Ren. I'm in the sunny place of Melbourne in Australia, and it's great to be part of it. I'm also a member of the Skoods Pro team. My focus is perception, deep learning. It's great to be here.
Thanks, Ren. Lau, the guy that is joining this live during the night. Hi, Alexandre.
Hi, everyone. Good evening or good morning. Or I am Alexandre Nogueira. I am a solution architect, and I work with autonomous systems as well. And I'm here to work and to support the Skoods team in the Pro team with these incredible simulations that we are creating here.
Thanks, Alexandre. Felipe, introduce yourself.
Hi, everyone. I'm representing the Vega team, and it's a pleasure being here. The Vision and Robotics Lab from UFMG. I'm representing, and it's so good being here with you guys, and it's my pleasure.
Our pleasure, Felipe. Thanks.
Pleasure.
Then, the trophy holder.
Hello, my name is Steven. Good evening for everyone. I'm representing the autonomous racing team, the RT team. There are some friends from Embraer and Attack, company from Embraer. And you join this competition to learn with experienced people that are already working in this area. So it's a pleasure to be here also. Thank you.
Thanks, Steven. Wesley, finally. So,
Oh, hello. Hello, people. I'm Wesley Torres. I'm from FATEC Santo André. I'm a professor there. Our course is related to automotive electronics. And we are here. I'm representing our team, FATEC Autonomous Racing. And I'm here and also our team to learn and compete. But the competition would be the more funny if we can try to learn as much as possible. And I'm very glad to be here. Thank you so much.
thanks, guys. So, let's dive in our simulation. Okay.
The best part.
Sorry?
The best part.
Yeah. It's going to be the first time that the teams will see it.
Yeah, it's a surprise for everybody.
Dun, 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 dun.
Some of the guys just see some screenshots, but now we're presenting the whole simulation.
Yeah. Can you see, guys, the screen?
Yep.
Yeah.
Thanks. So,
Yes, it is
the
amazing.
whole big picture of the simulation. Let's go up to this big environment. It's a mine with 400 meters deep, 1.2 kilometers wide. Okay. So we do have these roads that we built for this challenge. So it makes sense on the challenge that we are proposing. We are going to show the rules, but let's see a little bit more about the environment. Sure, we have some dressing, right? Some equipment from mining, like these guys here. We have Guilherme did a great job on modeling all the simulation. Thanks a lot. Here's when we were born, there in the end, in the back here is where the cars will born, the trucks will born. And here is the unloading spot, okay, the unloading point. We are gonna understand more about the challenge as we show here. So when we get here, we have this intersection with 3 road segments. One road segment goes straight to the pit here, down here, to the loading spot. But we still have all these 2 other options here that we're going to talk why we have all these options here. So
Wow, this is amazing.
right? Let's talk about the rules. So what's going to happen is that teams will have to control 3 trucks at the same time. So it's kind of a swarm coordination, but actually a small swarm, right? Only 3 bees, let's say, but still a coordination. And the trucks can only be 1 truck per segment of road each time. You cannot have a line of trucks, okay, going down to the pit here, to the loading part of the simulation here, okay? So again, 1 truck per segment of road. What is a segment of road? This piece is a segment of road. Then we have an intersection. This up climbing here is a segment, and this other long here is another segment of road. And the goal is to control the trucks to come down here, load, and then go back to the unloading spot here. Also, there is one big thing that happens every 15 minutes. So every 15 minutes, one of the road segments will be blocked. So you can only get out of a road segment when it's blocked, but you cannot enter a road segment when it's blocked. So it's a operational research challenge. It's more focused on the planning side of the software stack for vehicles, autonomous vehicles. We're going to show this image explaining this for more discussion. But before that, I would like to play the simulation, right? Teams already are used to how we run the code here. It's pretty simple. So we start the simulation, gonna run the code. On the side here, it's a Python code. Then we have it. So the green dots are the debugs of the LiDAR system. So lasers getting distances from points. Very important for the perception side. We also have cameras. We can have any number of cameras in our trucks. We can reposition them. We can change the lens. We can make fish eye. It's not too much to say that this is the best simulation environment in the world. That's why a lot of companies use it not only for engineering but also for marketing and movies. And to give you an overview, not only one truck to be controlled, but 3 trucks. This is our small swarm.
Fernando, can you, it's possible to come closer to the trucks and in the environment to see the details of the materials and also details of the truck?
Do you know, guys, very first time I worked in my life, I worked in a mine in Vale in Brazil, and it looked pretty much like this place. So it brings me back beautiful memories.
Thanks. Thanks, Ron.
Wow, look at the truck.
Yeah, we try to catch the mining environment the best as possible, and to the challenge be very close to the real environment. For sure, it's not complete. It's not 100% as the real environment, but all the teams we need to think a lot about a strategy, how to load and unload all the rocks, the mining or.
What did you model it on? Was it like what brand? Do you know the truck?
I'm not an expert about this, but Fernando I know is Alexandre is and Felipe also. I'm not an expert about
I
this.
can tell you guys, it's really amazing. I mean, if you talk about mines, they're all about operational excellence and also safety. And here we have a perfect mining environment, and you have blockings on the roads. You have other vehicles crossing by. It's really nice. It's really close to an open pit mine. That's fantastic work, guys. It's really nice.
Just for the audience to know, okay, it's the first time that the team is seen as well. We wanted to do a surprise for the team, so it wasn't. We didn't speak before, okay, guys. Fair, honest feedback here.
Yeah, coming from you, Alexandre, that is very experienced guy in the mining industry. It's a compliment. Thank you.
It's really nice.
Because Fernando, I have experience in the mining industry, but I'm not. I don't have experience in the mining industries. I mean, I have experience in software engineering, so I also learning about the mining industry. It was very funny to do something that I never have done before.
This brings back beautiful memories. I remember exactly that. I've been in one of those trucks myself. So
yeah, great. That's very nice.
Yeah.
And the best part is that you don't even need to clean your shoes later on.
Absolutely.
That is fantastic. It's really,
All
really
from
nice.
the safety of your home.
Guys, please make, if you have questions, the teams about the rules, let me show the rules here. And I was controlling the simulation. Now I'm gonna show this overlay here. 1 second. So here are the rules, 9 rules. Competition duration of 1 hour, sure. In the day that we present the competition, we are gonna compress it. 3 vehicles working in sync. Segments of road have speed limit and can have only 1 vehicle at a time. 4, vehicles must load at the loading point and unload at the unloading point. 5th, to load and unload, vehicles must stop for 5 seconds at the loading and unloading point. 6, same algorithms for the 3 vehicles and 1 central brain to coordinate. So, we cannot have predefined, algorithms for each of the trucks. So it must be dynamic with this one algorithm. 7, every 15 minutes, one random segment of road will be locked for 5 minutes. So we also bringing a dynamic characteristic or feature for the competition. And finally, 8th, when a segment of road is blocked, vehicles can leave the segment but cannot enter. Finally, 9th, the team that unloads more wins.
When are we going to have this available to download? Is it available right now?
Yes. Guy can send you guys the simulation. We just need some fine tuning on the truck, on the model of the truck. We need some more power to the truck, more traction to climb some hills there. Yeah, I think that's the only final touch. But as most of you are using PID controllers, not model-based controllers, so it's not going to be a problem for start playing.
We can release a better version for you guys start working and be familiar with the environment and with the competition, how the contest will be, and for sure for the contest we have to make some changes yet, but a better version for you we can release maybe the next week. I can I believe we can do that. We'll be able to release a better version the next week.
Also related to the details, right? This is the high detail simulation. As we did for the first competition, we are releasing one with lower textures and requires less resources for the teams that don't have big GPUs.
Brilliant! It looks amazing.
One thing that of this simulation seems to be more efficient in terms of processing than the last one. Seems to be, at least. We believe it's more efficient than the last one.
Yeah, much more. Yeah, the LiDAR points, the simulating the LiDAR is much more efficient now.
And one thing that we change is the central camera. It was a segmentation camera, but in this kind of environment that is very difficult to do segmentation, we changed the camera for thermal camera. So it's an infrared camera. because segmentation in this kind of environment is very challenging. It's almost useless.
It's all the same color.
Exactly.
For the audience to understand, so before we had a segmentation camera, which is pretty useful for training AI algorithms. You can label each pixel and classify every single pixel from images. But in this, this all gray or budge environment, it's useless for us here. So we are using the thermal camera.
Yeah, it's very difficult to classify all the pixels in the labels. So yeah, we choose to use the infrared camera.
I have a question.
Camera, please.
First of all, congratulations for the great job. It's really nice. The simulator scenario, it's really impressive. And regarding the perception, are we supposed to detect obstacles? How do we detect which segments are available, are blocked at each time?
Yeah. So about the perception, no. For this first mining challenge, we don't need to detect dynamic objects. So it's mostly focused on the way that we did for the racing, for the first race. It's about mapping waypoints, connecting waypoints, and taking decisions on which paths to take. So probably using finite state machines and other decision trees to take decisions on which paths to take. And sure, based on the waypoints that you guys record. Because we want to focus this challenge on the planning side. The first one was control. The second one's planning, and definitely the next challenge, which is the port, will be focused on perception. Basically, so and the second question is related to how do we know the segments are blocked, right? So
Yeah, that's right.
As the truck can be anywhere inside the segment, we are going to send some orders from this from the environment to the car saying which road is blocked. So each car will receive. You can consider it as an array of which segment of road is blocked, and then you can only get out of it. You cannot enter this segment of road. Did I answer your question, Stephen?
Yes, and somehow I think that you need to know at which segment each vehicle is. So I think it's supposed that our software to map this to be aware of this. I think, or the scenario is aware where each car is.
Do you already know
Here.
Do you already know which segments we have? How many distinct segments we have?
Oh,
sorry, Ram. Can you repeat?
How many distinct segments do we have? I think that this map probably responds to that.
Yeah, that's
so
right.
let me put this one here. This guy here.
Okay, cool.
To answer your question.
Mhm.
1, 2, 3, 4, 5, 6, 7 segments.
Mhm. Okay. So it's like a Hotel California backwards. You can leave anytime you want, but you can never enter.
Great, Ren. Great.
So we have a question from Professor Kitani here. The load and unload the trucks will be automatic. Yes, Professor, we just need to stop the truck in particular points for 5 seconds and it will be done automatically. And the audience, if you want to drop some questions here in the comments, please do so. Okay. Let me show you this other image here. This is the general overview of the whole map. And I know, guys, you all teams, you are very collaborative. So if you have any, if you can raise the challenges that you see, if you can raise already some solutions that you already see, let's discuss on these. We still have some 10 minutes to do it.
So just make a comment, Guy. It's brilliant. I look forward to starting the competition on planning.
Yeah, this one I'm pretty sure will be very very nice, very funny. To yeah, I'm pretty sure about this.
I absolutely look forward. Brilliant work, Guy. Thank you.
Let's
Thank you
bring
for the
this,
compliment.
let's bring this small pipeline for the algorithms development. So the first competition we had this challenge which is related to vehicle control. So I guess all the teams completed the first competition. So we are ready for the vehicle control box here, okay, or module. And now we have this swarm coordination central brain, which we can see it as a high level planning algorithms in which you have to take strategic decisions. We can use algorithms, just search algorithms, greed search algorithms. In this case, we don't need to be greed, right? Because it's just 7 segments of road, but we search algorithms to take decisions on which segment to take, and more variables we take in consideration to build the search algorithms, like where each car is in the segments of road, what is the time it takes to reach the end of the segments of road. So all these more variables that we include in the search algorithms, a better prediction or better decisions we can take, strategic decisions. Okay? So these, I think, the swarm coordination box here, or module, is the, I guess, is the winner module. But we do have the vehicle planning, or we can, let's call it path planning, low level path planning, working with waypoints, connecting waypoints. That is also important for this challenge. I don't see this as being a winner effort, but it's definitely at least you need a decent module on vehicle planning, waypoints, definite state machine. So defining the tree, the decision tree, so you don't make mistakes, and probably some functional safety around, avoiding any wrong decisions related to the planning. So as you can see, guys, it's mostly a planning challenge.
Let me ask you, is there any communication constraint between the central brain and the vehicles, like bandwidth constraint or latency, something like that?
Nope. But what we are planning, Steven, is that local control is in the car's algorithm.
Yeah.
So vehicle control and vehicle planning is edge computing, let's say. And then swarm coordination is cloud computing. But I don't see any constraints here. You can know where the vehicles are with their speeds. It's the central brains, the ones that see it all.
Interesting.
And actually, you can consider the communication between all the vehicles almost instant. So yeah, it's very fast. You depend much more on your machine than actually inside of the simulation, but it's very fast, faster than real world.
Yeah. And are those interface between the swarm coordination and vehicles are defined and predefined, or we are expected to define those interfaces in terms of masters, which data we are exchanging between them?
Yeah, you should define this, Steven.
Okay, nice.
But we can, it's the way that I see it is just one more module in our Python environment, you know, one more file or one more folder. Uh, but yeah, I don't see any constraints here related to the central brain. You can.
Nice.
Yeah, actually, during the we have time into the contest, but we can discuss how to do that and understand your concern. And maybe it's possible some teams want to use ROS to do that. I'm just I'm not saying they use, but maybe they will think to use because it will be easier to do this kind of communication and exchange messages between all the trucks as a swarm coordination. But it's something that we can discuss. There is no problem.
Nice.
If, for example, if you want to use a Docker container, maybe, I don't know, and you want to communicate with the simulation, it's not an issue. It's just a configuration of the communication interface. If you want to use TCP/IP or UDP, it's something that is not. It's not a technical challenge. It's much more the way you want to solve the problem, the architecture you want to use, than a technical issue from our end. So it's something that we have time to discuss.
Great. Thank you.
Another question from Professor Kitani. Is there any possibility to the truck get stuck? So, Professor, no, but we do, it's required to do some maneuvers in the truck. So, in the unloading and loading points, we do require a maneuver. So, you maybe have to go on reverse mode and then forward. But no way it gets stuck because the segments of road you can enter, you can leave them, but you cannot enter. And sure, it can be. We have a possibility that trucks will stop and wait for the segments of road that are blocked, because the segments of road that are blocked are random. So you need a state, you know, to just stop and wait for the 5 minutes of the blocking segment. Another question here, is each truck dedicated to one of the three paths or trucks could alternate? Yeah, the trucks could alternate. No problem on that. It's all about mining more. With these 9 rules, who mines more wins. Okay.
I have another question regarding the simulation. Are the sequence of random blocks different at each time, or I'm supposed that when you run the competition, it must be the same to be fair with all teams. But when you run a single time, is there a way to predict which sequence of blocks are will be realized? It will be actually.
Understand.
Did you understand my
Steven.
question?
Yeah, definitely. For the competition day, we are going to generate a random sequence of blocking segments, and we use the same sequence for all the teams. Okay, definitely, because it's going to be equal for all the teams. But for the training, for your training, guys, it's important to have this random behavior. So developing the simulation with the random feature applied. Because in this way, you are prepared for what's coming for the final competition.
But I think it could be nice for us to control the seed of this random feature. So somehow I think it's a good idea to expose the seed of this random sequence for us to be able to exercise the same sequence of blockages. because it's very hard to, when the scenario is continually is running, you cannot reproduce what you observed in the last simulation. So I think it's a good idea to expose this seed for us to test. It's just a suggestion.
Perfect. Let's do it in our weekly meetings, the race weekly meetings. Just explaining to the audience, every Wednesday during the night we have a competition meeting with all the teams and all the members. Right now
Great.
we are 29 people working together, right? It's amazing, right, guys? 29 great minds working together around this challenge.
Nice.
Fernando, a quick question.
Yep.
Can you hear me?
Perfectly.
Oh, yeah. Have you guys already established the truck speed limit or
The truck, sorry, speed limits?
the truck
No,
speed
we are
limit?
going to
Yeah.
define with you guys. We do have, just like in our past competition, we have a few things that we define beforehand, and then we have some features to define with you guys in our weekly competition. But mainly, let me show you here, mainly the idea is, first, wait, let me just check it. So, can you see this, the road segment up there? The one above all of them? Can you see, Felipe?
Oh, yes.
Yeah.
Yes.
No,
Yes.
it's the one above. It's the longest segment, and it's narrow. It's a narrow road. So we are planning to make it without speed limit. You can go in any speed here. You know, it's like if you want to try it. Okay. Then define the speed limits for all the next segments of road. And to define these, we're gonna align during our weekly meetings. Okay, we do wanna reach to the limit of speed in these narrow roads here, but in this big, large road, we don't want to, we want to maybe low speed limit. So we have a very defined constraint for the challenge.
Fernando,
Yeah.
are you still displaying the overlay image?
Oh, sorry. Thanks, guys. Let me know when I do something wrong here, okay?
Now we can see it.
Yeah. Just checking comments. So guys, teams, Skoods, any more questions here related to the simulation? I think recovery covered most of the discussions here.
I have a last question regarding the simulation. As far as understood, they are not supposed to stay in the same segments. Is that right?
Yes, the trucks can't be two trucks or two or more trucks in the same segment, but in the starting point. Okay, sure, in the starting point they will be in the same segment.
They will be in the same segment.
Yeah, you should accelerate one at a time. Go one, Then after you leave the segment, go the second, and after leaving, go the third.
Yeah, I just like to understand, is there any safety, just a link with the real world, is there any safety issues regarding this? Is is it is it related to the real world, this assumption?
In real world, minings work pretty much like our urban roads, right? If you have a very narrow road, it's only one path, one way.
Oh,
But definitely in this big, large road in the middle here, it could handle two ways. But we define this just for the sake of the challenge, like creating constraints.
Yeah. If I'm not wrong, there is some in some part of this track there is a vehicle stopped there, isn't it?
Yeah,
To as an obstacle.
kind of. It's in the side of the road, so
Yeah.
it's an obstacle, but not that important. Yeah,
No. Okay. But it's exactly as it is, I would say. Yeah. That's really
yeah,
nice.
yeah. We can put some more obstacles in the roads as well. Let's discuss in our weekly meetings. Yeah.
because I think they must wait at some point along the segment to for the other truck to complete the segment, I think. Or they is there any place to stay to wait for the other vehicles to pass by? Is there this kind of locations in the map, in the scenario actually?
Mm, no, no. It's if you're in a segment, you are in a segment. But that's an idea for our meetings. Could be. But the idea here is that the intersections, you
Yeah.
must use the intersections very well. In this big ramp here, sorry, let's show some. So this big middle ramp here, climbing this road there, uh, you do need some maneuver from the interception, from the loading points to climb it. So it's a path challenging as well there, in the intersections.
Interesting. I just wonder here if a better assumption is that two trucks cannot stay move along the same track at the segment at the same time. But maybe you can handle a truck that is staying waiting and
Uh-huh.
another truck that is moving along the segment. So they maybe this might be allowed, but
Uh-huh.
two trucks moving along the same segment might be not are not is not allowed. Maybe it's a different assumption. I'm just wondering here. But you can
Yeah,
discuss it later for
yeah,
sure.
it's a great idea, Steven. But I think that in this way we should have more than three trucks. But
Yeah,
and the
yeah,
problem
interesting.
about having more than three trucks is computing power. So not
Oh,
if the teams don't have a very powerful computer, putting more than three trucks could be, it could struggle. But definitely, let's talk about it. Maybe with ghee reducing the quality of the textures and so on, we can, maybe put 5, 10 trucks, and definitely it will be needed.
then you become a swarm.
Yeah, a
Yeah,
bigger swarm.
biggest swarm. Nice. Yeah,
Yeah, not
congratulations.
using the LiDAR debug is already a very good help for the GPU.
Yeah. Also using this quality here, which is more cartoonized.
Yeah, it's what I mentioned. It's I don't remember. It's F4. I don't
F3.
F3.
Yeah.
4, 3, and that you can downgrade the resolution, so you can use more GPU efficiently using more threads.
Very nice.
Yeah, this is something
Another question? Can I make another question? Oh, yeah. As we can see, the competition is very demanding, very complex this time, and we have some prize at this competition.
Price?
Some prize? Yeah.
You mean more rules or?
Like a gift, yeah.
Price. Great question. Thanks for the
Yeah,
question.
yeah.
Because we are communicating with some partners, some companies that may have some interest in supporting these. So definitely, we are looking forward to this. And I forgot to say before, thanks for remembering. We are planning awards for the teams and also for the team that collaborates more.
That's great.
Cool. Yeah. I totally forgot to talk about it. I was focused on the simulation side. So guys, can we finalize 2 more minutes for the last question if we have them?
Fernando.
Yep.
Professor Kitani just made a question here. Considering the objective of amount of load and unloading, any accident or crash will be penalized?
Not accident and crashes, especially because the loading part is at the bottom of the pit, so I don't see people crashing and getting better results. But definitely, if you invade a block segment, for example, you will be penalized, and if you reach if you go more than the speed limits of the segment, you get penalized. Not defined yet, these penalties, guys. Again, this is our rule as a team to define our meeting. All good?
Fine.
All set.
Excited, Wesley?
Yeah. Congratulations to you, Fernando, Guy. It's amazing. I cannot say any words. It's very, very well done.
Thank you. Thank you for the compliment.
Thanks, guys. See you next our weekly meeting and the audience in the next live event.
Okay.
Thank you, guys.
Thank you.
Bye, guys. See you.
Bye-bye.
Bye-bye.
Okay. See you.
See you
Bye-bye.
again.
You guys.
Bye-bye. See you.